Okay, folks, this one is a little longer than normal. It's got something like 40 slides in it. So let's break this up into some parts, and I'll suggest some places where you might want to pause if you want to take a short break or something like that. First of all, introduction to educational research. Why does it matter? The answer to that is actually fairly straightforward. Most of the things we do in the classroom is informed, or at least could be informed in some way, by educational research. So we need to understand what that research looks like and why it's important, or in some cases, why a particular bit of research is not helpful, for example. So let's see, we're going to take a look at these items. Those time minutes are for a face-to-face class or a Zoom class, so just ignore those. And then you can post any questions that you have in the discussion forum on Blackboard, okay? So here we go. Let's dive in. Why learn about research? What is it? Well, first of all, it almost always poses a question of some sort. It looks for a problem, or it problematizes what is often taken for received knowledge. And so we can collect answers, collect data to answer those questions, and we can present an answer to that question. And very often we want to state what our limitations are. One of the things to keep in mind while you're reading is that most of the time, researchers and educators in education do not say that their research proves anything. And that's because it doesn't. It usually contributes to a larger database, a larger conversation. And so we don't prove something. Data suggests. When we're dealing with something as messy as human beings, the most that data can do is suggest this possible course of action, this possible cause for a particular phenomenon, and so on. And then we present the answer to that question in that context. We're not out to prove anything because, well, we can't. Okay, scientific method. I'm not sure why this slide is in here, but let's go over this in any case. First of all, there's a selection of a problem. Right now, COVID-19 is a problem, and everybody recognizes it. So we've got to formulate a hypothesis or research question. Will injecting Clorox cure people of the COVID-19 coronavirus? So there's our hypothesis. Our hypothesis being that it will not solve it will not cure the coronavirus. Then we collect some data. We find some different ways that we can do that. Hopefully there would be nobody that would be so stupid as to volunteer for a clinical trial of injecting Clorox, but you never know these days. Then we do some analysis of the data, and then we make a conclusion about that data. And we're going to take a look at a quick overview of how that's presented here in just a couple of moments. So moving on. That is a kind of a funny picture, isn't it? Clever. Parts of a peer-reviewed academic journal article. Once you've done some research, generally you want to disseminate that. You want to share it with other people. We have a phenomenon in the research world at all levels: medical, biology, education, of what's called publication bias. You don't have to remember that necessarily as particularly the term, but publication bias is always looking, suggests that interventions or studies that produce a positive outcome or result are usually going to get published. Those that do not produce an observable result or outcome don't get published. And that's unfortunate, because sometimes we learn as much from what doesn't work. If we're going to be injecting some sort of simulated human being with Clorox, then we would want to know that that doesn't work for absolute certain. And a study that makes that claim, providing it didn't hurt anybody, would be a valuable study, at least to some people. So here we have the parts of academic articles. This is a construction by Creswell. It's taken out of context. I don't have this book with me right here in Egypt. But generally you can see that we've got a research process, and we're going to report that in our journal write-up, in our study write-up, our dissertation or our thesis. We're going to report that. We're going to state the research problem. Here's why this is a problem. We're going to look at the literature that exists, the extant literature, and make some determinations about what other people have looked at. And this is one of the reasons why we know that data suggests, but it doesn't necessarily prove anything, particularly in quantitative inquiry. I'm sorry, qualitative inquiry. From that, we develop some research questions, and we can take a quantitative approach where we're using numbers, which we're going to return to here in a little bit. For the most part, that's an oversimplification, of course, or qualitative research, where we do things like focus groups, interviews, observations, and so on. We come up with a research design that is suitable, and there are any number of research designs that can be used to address these. Sometimes they're overlapping in case of quantitative or qualitative research. Sometimes they're specific to one or the other. We can also have mixed methods research, by the way, where we use some qualitative and some quantitative. Cresswell and Plano-Clark have done a good job of explaining how that looks. Once we've chosen our design, and those are examples, by the way, and action research, I'm not sure why that is in the combined design, because it's not always a mixed method. It's not always a combined design of both quantitative and qualitative. It can be only qual, it can be only quant. Usually it's qualitative. Occasionally it's combined between the two. Then we determine our sampling. We're going to talk about that in a little bit, so buckle in. We're going to talk about the instruments or protocols that we use. Most of the time, we've got some sort of an instrument that we're going to use to collect data. If you see somebody in Home Depot and they've got a clipboard and they approach you and they want to ask you questions, whatever they're marking on that clipboard, that's an instrument. A protocol is just a set of standard procedures for gathering data. And we use these because we want to gather the same data in the same way for whatever our various research subjects happen to be or the phenomena under examination. We need a plan for data analysis, how we're going to look at that data once we've collected it, and then we need a plan to interpret that. What does it mean, if anything? One thing that I think is missing here is that we need to report what we have found. And I'm not sure why it's not in here, because this is actually the foundation for the research. We need to report the findings or the results. And you're going to see these terms used, and there's a slide later on that I didn't change on purpose, but actually those terms are used interchangeably, and they're not interchangeable terms. Findings are always qualitative data, and results are always quantitative data, always, unless somebody just doesn't know what they're doing. So if you see findings and you see results, they're not the same thing. The words tell you something. Results, it's a quantitative study. Findings, it's a qualitative study. In the case of combined designs, mixed methods, for example, depends on who you ask, but my recommendation is that if you were to do a study, you would call it, in a mixed method study, results and findings, though Cresswell and Plano-Clark would insist that we just call it results. So that one depends on who you ask. Then we take a look at the discussion section. We discuss what does all of this data mean. We relate it back to the literature review. We may draw some conclusions. Limitations are an interesting section also, because in limitations, we want to state that there are some things this study did not examine. We didn't try to examine this or that. That's a delimitation, or a limitation that shows, look, we had a small sample size. That's a limitation. Or we have a sample size that's not completely representative of the population. We're going to come back to that. Limitations tell you, and delimitations tell you, what the research was trying and not trying to accomplish. And it draws the lines around those particular parameters. And then very often there are suggestions for future research. What might happen next? Okay, so I have no clue what the circles are on the right-hand side of the screen, why the one's bigger than the other and so on. But in most papers, most journals, not all of them, by the way, but in most journals, you're going to see that there is an abstract, and you've seen that the APA recommendations in the APA tutorial that we did last week have a recommendation, but actually publishers have different abstract requirements. If you were to write for publication, that might be a 500-word abstract divided into certain categories, or it might be 150 words. It just depends on that publication and what their needs or uses for the abstract are. They're useful for a couple of reasons. If you write an abstract, then you have clearly synthesized what your research is about, and it's probably the last thing you should write, even though it's the first thing that appears. Talks about the purpose, the methods, and the results, or findings, of course. And of course, there is a title also. So moving right along, when we open a journal article and we begin to read, we'll almost always see these parts. Parts are parts, but sometimes the parts have slightly different names. Introduction, for example, a statement of purpose is included in that. The review of literature, a literature review. That will usually include the research questions, though you sometimes find those in different order in this case. But the introductory material sets the stage. What's the purpose? What's the problem? What does the literature that exists already say about this particular problem? And then, of course, what are our research questions that we're going to attempt to answer in the research? Now, remember, you're only writing a literature review. So you're not going to have all of these other parts, but you'll be reviewing literature that does. All right, so here we go. After the introduction, we get everything set and we have set the stage. We have a method. It's going to be quantitative or qualitative or mixed methods. And I believe that video is, well, I don't know where that video is. I'll have to find it and link that for you. And we come up with a design. We do this in advance. Typically, I mean, it can be done afterwards with existing data sets, but typically what you're looking at is a method that has been set up so that everything is followed in a specific order. It's replicable. That means that some other researcher can come along and say, okay, I'm going to see if I can do this the same way by maybe changing the participants a little bit, or by using a slightly different instrument, or I just want to see, I think there's an error in this. So our method is always set up in advance, and it includes these things. What's our design? Is it going to be a case study? Is it a phenomenological study? Is it survey research? Any number of things. We identify who our participants are, who will be taking that survey, who will we be interviewing, and so on. We're going to talk about sampling in a little bit, so I'm going to skip over that. We identify the instruments. I'm going to use an observation instrument that's a check sheet. I'm going to use an interview protocol that asks these specific questions, and so on. I'm going to tell how I analyze the data. I might use a particular program to do that. I have a systematic way of looking at the data and so forth. And if you're interested, I can provide examples of that for you and a method for interpreting what that data actually means. What does it actually tell us? Okay, so moving along. We're at almost 13 minutes already. So here I have added the word findings because previously the two were confused on this slide. As you already know, results are for quantitative studies or sometimes mixed methods, and findings are for qualitative studies. So in the results and or findings sections, we're going to take a look at the research questions. We're going to go through them step by step. Sometimes they're actually printed right out. Other times they're given shorter names, subheads, and so on. But in general, this is where we're going to find that those research questions and trying to answer them from the study that we have conducted. We want to answer questions about generalizability. Again, this one's important because generalizability is specific to quantitative studies, not qualitative. If you've interviewed a bunch of people and observed them doing certain things, you can't really generalize that. So in qualitative research, we don't generalize. Instead, we do the opposite. We describe very well what the study was, how we conducted it, what the data shows, and then we allow the reader to generalize it to their own situation. These conditions are like my conditions. These conditions are not. Okay, so there is a big difference there. Generally, quantitative inquiry is generalizable if it's done well. If it's qualitative with interviews and more subjective measures, it's generally, I made a joke, generally not generalizable. Instead, it's up to the reader, the consumer of that research, to determine what elements of it apply in their studies, okay? Often there will be a section with recommendations, future research, a discussion of what all that means, and so on. And as you read, you're going to start to see these patterns. Even if the names are sometimes just slightly different, you'll still see the same pattern in almost every research study that you read or have read so far. So moving along, coming up on 15 minutes, so this may be a good place to stop here in just a moment. Of course, every study has a reference section, references cited. This is different than a bibliography, by the way. The references are the ones that are actually going to appear in your writing, those parentheticals that you examined last week. Those always have to match. There won't be any book or article in the reference list that's also not cited in the literature. There are, a bibliography may or may not have all of the same citations. So there is a small difference, so don't use those terms interchangeably. Also, most people skip right over the reference list, but I don't think you should. Here's why. You're looking for a literature review, so you want to become familiar with who has been cited in the past. This sometimes runs a little counter to our notion that we want works in the last 5 years, for example, but it's still a good way to start to recognize who are the names in the field who do this sort of research. What articles have they written? Which ones can I search for next? And which ones can I search for that might be newer? And the reference list is your place to start. All right, let's take a quick break. And move on. Note the time. My index shows 16 minutes, 26 seconds at this point. We're going to take a look at variable types. Now listen, this is often confusing, and it's often confusing because a lot of people are often confused by it, and then they explain something that's not actually the case. Variables are almost always associated with quantitative research, with numbers, okay? Something that we can clearly determine is a variable. There are some who claim that variables can be applied to qualitative research also, but I think we don't have to worry about that too much in this case. So we have variables here, an element, a feature, or a factor that's liable to vary or change. Age is a variable. At my age, I have to start paying more attention to exercise and diet and so on. It might not be the same. It's equally important perhaps, but those variables might be different if I were 25, for example. An independent variable is the one that can be manipulated by the researcher, and it can have multiple levels, by the way. The dependent variable is the one that is measured. Now, you can start to see why in qualitative research, we don't generally talk about this much, even though a lot of people try to misapply this to qualitative research. It's just generally not possible or even desirable to make that distinction. But for quantitative research, it's really important. You have to know what it is that's being manipulated, what's going to be changed, particularly in experimental research, where the experiment is manipulating some aspect of the environment, for example. Okay, so here's a nice little quote. Says in non-experimental research where there is no experimental manipulation, the independent variable is the variable that logically has some effect on a dependent variable. For example, in the research on cigarette smoking and lung cancer, cigarette smoking is the independent variable. The one seems to cause the other, and that's what we're going to study. Whether we do that qualitatively or quantitatively, you could possibly make that argument, but I wouldn't do it in the case of qualitative. I just wouldn't go there. But it is an important factor because even though we might not be manipulating the cigarette smoking in this particular experiment, we can find the right correlations. We can find the correlations that show that the one is linked to in some way the other. That's correlational research, and sometime ask me and I'll show you some really funny correlational research studies. Okay, so we have measurement scales, systems for organizing data so that it can be inspected, analyzed, and interpreted. Range of values or scores for each variable. Important because different measurement scales allow for and require different methods of statistical analysis. Relates directly to the design of a study. Certain types of analysis require particular types of data. That's a mouthful, isn't it? So let's take a look. Here's Albert. He probably never wrote that on a board in his entire life, but maybe, I don't know. Nominal, ordinal, interval, and ratio. It doesn't really matter to me if you don't remember the exact names. You can always look these up, but do know that measurement scales come in different flavors. A nominal scale is something like eye color, blue, green, brown. It's a type of school, private, public, elementary, secondary, and so on. These are categories and they're nominal, but they're not ordered. We can say, I'm going to test the effect of this chemical on students with blue eyes, red eyes. Now, let me take that back. Red eyes probably wouldn't be a good example. We're going to test this iVisine solution on students who are having difficulty seeing in class with brown eyes, green eyes, and blue eyes. But I could just as easily say blue eyes, green eyes, and brown eyes. It wouldn't make any difference what order they are in as far as the data are concerned. There are survey bits that go with this that could make a difference. For example, you probably notice in the upcoming election, if you've got your ballot or the sample materials, that some items on the list are not presented necessarily in alphabetical order. And the reason is that if you were going to vote for, let's pick a past person, we might pick Barack Obama with an O, but above his name will be John McCain with an M. Sometimes people who aren't very thoughtful about these sorts of things, or they're in a hurry, will pick the first one on the list. But that has nothing to do with the value of the individual categories. Ordinal variables, on the other hand, are always in an order: low, medium, high. Educational experience: I've been to high school, I've been to some college, I have an associate's degree, a bachelor's degree, a master's degree that all of you will soon have, and so on. Okay? They're not necessarily equal, they don't have the same necessary value, but they are always in a particular order, hence ordinal variables. Okay, so you want to look for that when you're analyzing data, if you do a study, or when you're reading somebody else's study. What type of data is it? Why did they choose that? It's actually a very common mistake to use the wrong sort of information, the wrong sort of data, and mispresent that in your report of the study, whether it's a conference or paper you've written or so on. Interval variables are just like this. There's not a real zero value, but they represent equal intervals, A, B, C, and D. They're exactly equal. I'm trying to think of another good example of interval variables. Maybe I'll come back to that. We'll have to see about that. It's important to know too that different types of charts, whether it's a line chart, bar chart, scattergram, are associated with different types of variables. And this is again where people get into trouble. They use line charts where they have interval data, for example, and that would not be appropriate. Ratios, you can see the example here is a pretty darn good one. It has a 0 point, which means that we can compare different bits of data by using a ratio. For example, the difference of heights of basketball players, who is twice as tall or who is half as tall, and so on. Ratio variables also play an important part in a lot of research that we do in quantitative studies. Here is a variable practice exercise, and I guess I'll share the link, but I don't really know that you need to spend any time with this, but if you want to, it'll be there. I'll put this in Blackboard for you. There's a Google Doc, and you just want to make a copy of that. They want to determine the independent and dependent variables. Now here's the problem. There's not enough information to actually make that determination. We can assume that in each of these cases, there is a numerical component. So we can kind of assume that it's one of those sorts of variables that has a number associated, and it's not qualitative research. But we don't really know how the research is being conducted if we don't have the methods section figured out. If we don't know what the methods used were, it's difficult to tell what the independent or dependent variable would be. Is high school GPA a good predictor of college GPA? Well, we can assume that provided that there is a 4.0 scale at both college and high school, or we can standardize it in some way, that the independent variable is the college GPA, because that's the one that can change. And the dependent variable is the one that's a fixed quantity. So as you can see, this is not really something I think you need to worry too much about, other than to know that it's a component of a lot of studies. Finally, you want to take a break? Let's take a break. And the time is 25:20 according to my index. We're almost to the end here. So, validity. Hang on to your hats here with this one. You're going to see references to validity and reliability. A valid study uses instruments that measure what they're supposed to measure. And that might seem like, well, of course, why would that be an issue at all? But there are actually levels of validity, and also there are often tests that are not valid that are presented as being so. For example, when I was a kid, way long ago, there was a test that was given to us. It was purported to be a spelling test, and it would give us 4 words, one of which was misspelled, and we had to identify it. And you might think, okay, that's a spelling test, but it's not. That actually measures word recognition. Can I recognize a misspelled word? It does not test whether I can actually spell that word, and those are 2 different things. So that test is not valid. It was not a test of spelling, even though it purported to be just exactly that. And you can see some of the other issues there: unclear test directions, test items, subjective scoring, culturally biased information. All of those things are threats to validity. So this is the degree that a test or other instrument measures what it claims to measure. Reliability, on the other hand, is whether it does so consistently. So let's say I get on the bathroom scale, and the bathroom scale reports that I weigh 50 kilograms, because I'm in Egypt and that's the metric system that we use. It does that every single day, except I weigh quite a bit more than 50 kilos. But it's reliable because it tells me the same thing every day, even if it's not valid. So you can see what's highlighted here is the valid test is always reliable, but a reliable test is not always valid. Think about that. You'll come back, you'll see why that's true if you stop for just a moment and think about what that means. Knowing all of these sorts of things can help you understand the articles that you're reading, the studies that you were reading. What are they telling you? How are they telling you? What instruments did they use? What instruments could you use if you were going to do your own study? Which could be adapted, which could be used expressly as presented in different contexts. All of these sorts of things help us gather data and contribute to our understanding of how humans are educated. We're going to talk briefly about samples, which apply to all types of studies: qualitative, quantitative, mixed methods, survey samples, survey data, and so on. I'm just going to let you read that. I don't need to read that quote to you. Before we can talk about samples, we need to define a population. Here's a clue. In these examples, all 10th graders in the United States, all gifted elementary students in Utah, all first graders in Utopia country, wherever that may be, who have physical disabilities and participated in preschool. Here's your key. A population is all of the individuals. And for that reason, it's often the case that we have to choose a sample of that population. So try to keep these terms straight in your mind. A population is all of whoever or whatever. They're very hard to work with also, because how could you possibly have all 10th graders in the US as participants? Though it is possible to maybe have all 10th graders in a particular high school. It's possible, even though unlikely, but it might be possible. So instead, we very often conduct studies on samples. A sample is just a certain number of people who are intended to represent the larger population. Sampling errors. Sampling errors are kind of interesting in that we can do this in education research. If we want to look at Hispanics, African American population, Caucasian population, Asian American populations, and we conduct a study at an all-white or nearly all-white high school, then our sample isn't very useful. So we've got to know what the population actually looks like. What are the percentage of Hispanic, African American, Asian American, and so on within the population that we're looking at, and then construct a sample that matches as close as possible. This is, again, something that it can get really technical. We don't have to worry about it right now, other than to be aware that this is something that's important and that there can be errors made. So let's see. Yeah, there's a good article by Cook and Cook in the Blackboard Classroom. You'll find that there in week 5. How a sample is used, help you understand the extent of the results that can be applied to your own students. And this goes back to our discussion about qualitative inquiry also. You have to decide whether a study can apply to your students. And to do that, you have to know something about who was participant in the study in the first place. So we're going to go through this really quickly because you can come back and read this later on. And you're probably getting a little bit tired about now. Probability samples. All the members of the population can be specified prior to drawing the sample. Each member of the population has at least some chance of being included in the sample. If there are 20% African Americans in the population, there should be about 20% African Americans in the sample. So you see how that works. And the probability of that being the case would be measured and reported. Here's some samples. The examples would be random samples, literally drawing names out of a hat. Cluster sampling. We have some pre-existing groups. These are very common. A researcher has 10 sixth grade classrooms to choose from, selects 2 classes. I'm working on a study right now here in Egypt. We have a foundation that runs what they call community schools, and they have something like 1,000 schools. Well, we haven't got the money or the manpower, the person power to conduct the experiment in all of those, so we're going to work in 100, 50 control and 50 experimental. All right, so let's see, moving along. Systematic sampling. This one is actually pretty straightforward. Just pick every 5th person from a list, every 10th person, whatever it is, and as long as the list include members of the population, all of the members of the population, then you will have a systematic sampling. Stratified random sampling, you'll actually see this quite a bit too. We're trying to look for ways to reduce underrepresentation of a population, and this is one way to do that. Notice the sort of reddish, purplish, I don't know what other that color is twice as big as the blue and green. So in order to get a representative sample, we've got to do some stratification to make the appropriate conditions for generalization. I'm going to just let you take a look at this. You can see rather quickly, though, 10 black times 10% is 1 black student. If there are 10 black students in the population, that's proportional. Okay, or disproportional. We have representatives of every one of the populations, but it's not a ratio, it's not a direct proportion, hence disproportional, of the actual population at hand. But it does have somebody from every one of the study groups in it. Sample size is really important. When we talk about sample size, I just published a study last year with some Syrian refugees. The students of Syrian refugees, we had a sample size of 10, but it was qualitative research. On the other hand, we want, for this other study I mentioned, the one at the community schools where we're looking at reading, we want a considerably larger sample size because we'll be doing quantitative analysis, and we want to make sure that the sample is representative of the students in first primary, essentially first grade, from throughout the country. And there are a lot of variables to consider: socioeconomic status, parent education, rural, urban, and so Here's a random sampling activity. You can go ahead and do this on your own if you would like to. And I meant to delete that. So there you go. Oh, okay. Take a look at the last line. Major randomized controlled trials avoid non-probability sampling. Randomized controlled trials are usually quantitative in nature, and non-probability sampling defeats the fact that we're looking to represent a particular population. But that doesn't mean that it doesn't get used. There are some different methods for non-probability sampling. Easy for me to say. Convenient sampling is one. If you have access to a school that has a population of students similar to the ones you want to study, the population you want to study, that's a convenient sample. You have access to that school and not other ones. Quota sampling is along the same lines. I just need 5 schools. That's it, we're done. Purposive sampling involves making some judgments about who might represent that population in some specific way. I want to have a purposive sample of administrators who have some experience with special education. That's a purposive sample. And I choose those people based on that qualification, even though I haven't really done anything more than make subjective judgments about that. So you are going to be surprised. We are at the end of this 37-minute, give or take, presentation. Hopefully I did not talk too fast, but you can always go back and take a look on your own. I'll post the slides and the video so that you can take a look. This is not, by the way, on the YouTube channel that I set up for literature reviews. It's just too long for that. Why would you use non-probability samples? I think we answered that question. We can still gain quite a bit of information from a non-probability sample, but most important, we're at the end of this presentation, right on the mark at 37 minutes and 3 seconds. Let's talk about it in the discussion board.